Welcome to the Code with Reza channel. My name is Reza and I'm here to teach you Python. Today I want to talk about weird methods in Python classes. So let's create a vehicle class with init method. I add two properties, color and model, parameters. We already know that every time we create an instance of this class, the init method is called and it sets the color and model on the instance. Well, we can control the setting operation. Every time that we assign a value on the instance of the class, the setAttr method will be called and we can implement this method to control the assign operation. Let me show you. We need to define the method setAttr. In here, we say print setting this key to this value so that we can trace it and see if this method is called. And then I will say super, and I call the setAttr super method, and I will pass this key and value to the parent class. So let's create an instance of this vehicle and see what happens. I will come here and I will say v equals vehicle red and Honda. And let's run. So if you look at here, when we create this object, we want to set the color and set the model. Each time that we want to set anything on the object, if there is this method will be called. So here we are assigning color and model, two assignments, and the method is called twice. The first time setting color to reg, the second time setting model to Honda. And if you notice here, we call the super.setAttr method so that the values can be set on the instance. If we remove this line, then nothing really happens, and as a result, the values won't be assigned. So if we remove it, then nothing happens. But if we implement this method, every time that assignment happens on the instance, then this method will be called. In the same way, we can also control the retrieval of attributes by implementing the getAttr method. It gets called every time we retrieve an attribute. Let me show you. And the interesting thing about this getAttr is if the value that we want, if the attribute that we want is already exists on the object, it goes and gets without calling this method. But if the attribute doesn't exist on the instance, then it looks for this method. So for example, in here, I would say, let's put a print line to get some information, getting vehicle item. And in here, I would say if the item which is asked for. If it's info, for example, then return self.color and self.model. It's a tuple. Let me show you, it's easier when we see how it works. I will create an instance of the method and I will say print v.color. If I run it, it doesn't come into this method. We don't see this line. Have a look. To setting colors, that's fine. And it says red. It should be red, not red. So the color is red. It doesn't come to this method because it can find the color on the object. So in the same way, if I say print b.model, again it prints Honda. It doesn't come in here because it finds the model on the object. What if we say print, for example, info? v.info. The info doesn't exist on the instance, so it's not here. So the Python comes and runs this method to see if we are handling this information, and we are handling. So let's see what happens. This method is called getting vehicle info. It shows that this method is called, and because the item is info, it returns self.color, self.model. This is a tuple, red and Honda. So again, if a property exists on the instance, then it doesn't read this function. But if it doesn't exist, it reads this, it calls this function in this method to see if we are handling it. What if we wanna print something which we are not handling it anywhere? For example, print v.speed. So what happens is, for the last one, let me comment these three. For the last one, for the speed, it comes here on the self. Speed is not here. Speed is not here. Then it comes to get attr. There is no code for a speed. We are handling info, but there is no code for a speed. So let's see what happens. None. Here the print statement says that getting vehicle speed, getting vehicle item. So this item right now is a speed. This item is a speed. Are we handling a speed? No. So none is the result. We can also control the deletion of an attribute by implementing the del attr method. So let's have a look. Let me remove this part. Okay, we'll say if item equals color, print cannot delete color. We don't want to let the color to be deleted. So we will say cannot delete color and we don't do anything. But if it's not color, else we say print removing, for example, attribute, and then which we know it is model. So removing model, and in here we call the super to finish the work. We call the delete here from super and we say please delete the item for us. So here I'm calling vehicle, I'm creating vehicle, and I will say let's delete from the vehicle the color, and let's print vehicle dot color. Okay, So if you look at here, when we want to delete a property or attribute or field, it always comes and calls this method and passes that property as the item. So we check if the item is color, we just print cannot delete color and we don't do anything. So the color won't be deleted. And when we print it again, it prints it without any problem. Let's have a look. Cannot delete color. This comes from this line. And then when we print color, color is there, still there. So color is red. How about removing something else, the model, for example? Delete v.model and then print v.model. So this time it comes in here, executes this code. It's not color, it's model. So it comes here. It says removing, passes the model to the super, and everything is fine. So we don't have model anymore. So let's have a look. Removing model and none. The reason that it says getting vehicle model is because it goes in here. It goes in here. Why it comes in here? Because we remove the model doesn't exist anymore. So it comes in here, it doesn't find the model on the self because we have removed it. So it comes in here, says, okay, look it for me. And it says getting vehicle model and doesn't find anything. So returns none. There is the dir function which lists all the instance attributes. We can control it by implementing the dir method. Let me show you. Let me remove these lines and implement define dir. It's very nice when we want to see what's happening inside a class, to see all the attributes inside the class. For your own class, you need to implement it. So here I will add a comment, list of available properties. What properties here we have? Return, color is one, model is another one that we have, and we also support info. We also support info here. In get attr, we also support info. So we are saying we support these three infos. So let's test it. I will come in here. For example, I'm working with vehicle class and object. I want to see what properties, what attributes do I have? I can work with, and which one exists here, and which one I can call. So I will say print dir v. This dir, when we pass an instance, it calls this method on the instance. So let's have a look. Color info model. Now let's print the vehicle instance and see what happens. We have printed different properties of the vehicle, but let's print the vehicle. Let's see what happens. Main dot vehicle object at a weird number here. This is normally the address of the memory. So this is not very helpful. So we can control the string representation of our class object by implementing the str method. So there is another method here. We can say def str, and in here we can return whatever we want to be shown to the user. For example, return f. This is a self.color, self.model car. Now let's run print v. It should return this for us. This is a red Honda car. Look at here. This is a color red, model Honda, and car. This is a red Honda car. This is much informative. It's meaningful. It's useful. So we can also do that with our classes by implementing the str. Now let's look at some other interesting methods. Let me remove this class. So we have init, set attr, get attr, del attr, and dir and str. But we are all done with this. We want to explore more interesting methods. Let's create a Lego box class. So class Lego box. And let's initialize it. Diff init. And I let's imagine there's only one property, and that is pieces. Number of pieces that exist in this Lego box. Pieces. Set it on the self pieces equals pieces. That's all. So let's create an instance and print it. Okay. Lego box 1 equals Lego box with 100 pieces. Let's print it. Again, a very weird information which is not useful. So let's implement the str method to get more meaningful result. So in here, I would say def str, then return f Lego box with self the pieces. Now read it to see what's happening. Much better output. Lego box with 100 pieces. Let's create another Lego box with 200 pieces now. Lego box 2 equals Lego box with 200 pieces. And let's print it. So the first one is Lego box with 100 pieces. This one is Lego box with 200 pieces. Now a question. Can we add these two Lego boxes together? No. If we want to be able to add two instances of the Lego box class together, we need to implement the add or add method. Let me show you. So I will close this one and I will in here define add. I will say return a new Lego box with the first one pieces plus the other one, the pieces of the other one. So the self is the first one, the second one is the other. So I will say if two objects of Lego box are added together, create a new Lego box, add the pieces of the first one with the pieces of the second one. Let's try it. What if I say Lego box 3 equals Lego box 1 please plus Lego box 2? Let's print it. This one has 100 pieces. This one has 200 pieces. So it should have 300. Yes, Lego box with 300 pieces. So this is how we handle adding two instances of our class. How about subtraction? In this case, we need to implement the sub method so that we can subtract the instances of our class. So def sub return a new Lego box self the pieces minus the other pieces. So let's test it. Now let's remove this part and say Lego box 3 equals Lego box 2, which is 200, minus Lego box 1, which is 100. So the result should be 100. This is 200, this is 100. The result should be 200 minus 100, 100. Lego box with 100 pieces. There is another addition in Python which is called in place addition. We can implement it by implementing the I add. In this case, the first Lego box pieces will be updated. We don't create a new box. If you look at here in the add, we don't touch the first one, we don't touch the second one. We are creating a new Lego box. But with I add or internal add or in place add, we are not creating a new Lego box. We change the number of pieces in the first Lego box. So let's have a look. Define I add, and in here, self dot pieces plus equals other dot pieces. And then we return self. So let's see how we use it. And in here, I would say Lego box 1 plus equals Lego box 2. This is in place addition. And let's print Lego box 1. And also before this operation, let's print Lego box 1. So in here, Lego box 1 should have 100 pieces. After this addition, should have 300 pieces. Lego box 100 pieces, Lego box 300 pieces. But this time, we don't create another Lego box. We update the first Lego box with the new value. There are also some cool methods for comparing the class instances. For example, if an instance is greater than the another one, or less than, or equal. So for greater than, we need to implement the GT method for greater than. Let's have a look. Define greater than. Say return if self dot pieces is more than other dot pieces. Or less than. Let's define all of them. Less than is this one. This time return if this one, the pieces, is less than other the pieces. And also equal. If two objects, when two objects are equals, this is something that we need to implement it. The Python doesn't know. We say, okay, for checking the equality, we need to check the pieces. So the self the pieces should be exactly the same as the other pieces. If these two are the same, then we say yes, these two objects are equal. If the first one is less than the other one, we say it's less than or it's greater than. So let's try them. Print Lego box 1, print Lego box 2. Oh my god. And then here, the interesting part. Lego box 1 is less than Lego box 2. Lego box 1 is 100. Lego box 2 is 200. So Lego box 1 is less than Lego box 2. So it should be true. It is true. How about equal? Are they equal? Print Lego box 1 equals Lego box 2. Well, when we say equals, it comes and runs this method. Say, are the pieces equal? No, the pieces are not the same. So it returns false. Returns false. But for the first one, it is a less than. So it calls this one LT. It's very cool, isn't it? So calls this one and checks the pieces are less than the other one and say true. I really like this uh, functionality and availability in of these methods in Python because uh, we can't have something like this in some other languages. Like for example, in Java, you can't overload this less than or equal than like this. You need to implement it in another way. So this was the part 11 of this tutorial and I hope you enjoyed it. I will upload the next part very soon. Please don't forget to like and subscribe. Thank you for watching and see you later.